Now we'll see error control in TCP. In TCP we have two issues to discuss about error control. One is checksum, second one acknowledgements. Using these two we are going to take care of entire error control process. One thing, why we use checksum? Simple. Whenever a packet comes that might have errors, right? To detect whether a packet has error or not, we use checksum, right? After that, second thing, why we require acknowledgements? To control your sender, otherwise to direct the sender that, my dear sender, I got these packets, I did not get these packets. In that way, to direct the sender, we use acknowledgements. We will see how we are going to use acknowledgements. Before that, there are two kinds of acknowledgements. One is cumulative, second one selective. We will see one by one. So cumulative acknowledgements are generally like this. So they are going to represent some set of packets. Remember one thing blindly. So far, let's say you have received some packets with sequence numbers 100, then 200, 300. Let's say these are all consecutive packets P1, P2, P3. Then to represent all this information, we are going to send an acknowledgement ACK 300. Sorry. So this will be the next packet. Assume that let's say each packet is having 100 bytes, then here 300 to 399 bytes. Then we are going to send like this. My dear sender, I am acknowledging from, I don't know starting point, but all the packets up to this 399. The next byte I am expecting is ACK, 400. That's why I send ACK 400. Whenever ACK 400 is received by sender, so he will understand that the next packet should start with 400 sequence number. That is about cumulative acknowledgement. Second one, selective acknowledgement. Generally it is very rare, that is not popular, but people are nowadays implementing this selective ACK. What is that selective ACK you see? Example, let's say selective ACKs are allowed. That selective ACK is going to represent what are the bytes which are missing. Example, using selective ACK I can mention that, my dear sender, some 200th byte to 400th byte, this information is missing. In that way we can inform. That means we can just inform about some selective packets or selective bytes. Understand? So this selective ACK says like this in simply, my dear sender, some 400th byte to 600th byte, these bytes are missing. Now do whatever you want. Okay, do needful thing. In that way, so we can use selective ACK. But that is enough for us. We are not going into details of selective ACK because it is a, I can say, new thing which just now people are implementing. So the popular thing is cumulative ACK. We are going to study cumulative ACKs. Okay, let's begin with cumulative ACKs. So how to generate this kind of cumulative acknowledgements, and when we will see various cases. Generally, when you have data to piggyback, that means this is sender, this is receiver. Sender is sending some packet number 1. Okay, assume that let's say 1 is a sequence number. So whenever P1 is sent, then receiver is going to send acknowledgement immediately whenever there is a data. Understand? Example, receiver and sender both are having two-way communication. Already I told you, generally TCP supports full duplex communication. Assume that sender receiver both are having the data. Whenever sender's packet is properly received and receiver is expecting P1 only, then immediately he will send a data. Assume that let's say R has data already. This is let's say data packet of R. In that we piggyback this acknowledgement, right, saying that, my dear sender, this is data and ACK. We know that, right? In TCP header we have ACK field. Whenever that ACK is 1, that is nothing but acknowledgement. As apart from that, we can send the data in that packet also, right? So this is called piggybacking. Generally we do piggybacking, remember it. Now second thing, if no data to send, that means at this moment receiver doesn't have any data. If there is a data we can send. Okay, we will see statement one more time. Example, let's say you have data, sender is sending like this, it is packet number 1 and the sequence number let's say 100. For simplicity, from now onwards we assume that every packet has some 100 bytes of data. So whenever it is received, and receiver is also expecting same packet, and the receiver has data. Okay, so he is going to send his packets. Let's say we use separate information, we say S, okay. S1 is R's packet, and what is the sequence number we are going to send? 200. This is ACK. We say that, my dear sender, take my data, but also I am acknowledging that you have to send 200 because I have received 100. So this is what generally happens. This is called piggybacking. So that is the first rule you remember. TCP always try to do piggybacking, because when you do piggybacking, then you don't really require to send another acknowledgement packet. So congestion will be reduced in the network, right? So it's a long term view, I can say. Second one, what if no data is there? Example, receiver side there is no data. Then what we do is, we do one thing, we don't send the acknowledgement. Why? Because we don't want to unnecessarily send a small packet called ACK, because ACK carry very small information. If I send it unnecessarily, that information will, unnecessarily disturb all the routers, right? I don't want to do that. So remember that when there is no data, I don't send any acknowledgement. Now, what? Previous packet is also not acknowledged. Then what you do? See the situation. Already sender sent a packet. At that time you don't have data. You did not send. But what happened after some time? Sender sent another packet P2. It's having starting sequence number 200. I am assuming what? Data size 100 bytes everywhere. Just for easy understanding. So now see the story at receiver. Receiver did not acknowledge it, and he did not acknowledge this one also, because he doesn't have any data, because we are following piggybacking method. Whenever we have data, we send acknowledgement, so that we can save the time and everything. I mean, we can have efficiency. So in this model, what is going to be the problem? The problem is like this. What if there is no data for some long time, for 5 minutes? Then this sender eventually will become timeout. That means there will be a timer for every packet, you remember. Otherwise what happens, if there is no timer, there will be deadlock. That means how sender will, already we have seen in data link layer, generally every packet will have a timer, correct? Assume that, let's say there is a timer, maybe for every packet, otherwise for all the packets only one timer, whatever it is. So that timer will time out, then immediately he will send the packet again, because he is afraid that the packet is lost, correct? Because there is a high chance now that router is going to discard your packet. There is a high chance because of the congestion. We will be seeing the congestion in this one, in transport layer also. So we know that already network layer, we have studied network layer, and we have studied that there is a congestion in the network. So because of the congestion, sometimes your router discards the packets. That's why sender is going to send the packets again and again if you don't acknowledge it. That is the way things work here, remember. So then what we have to do? We have to use some strategy. Here we are just discussing, try to understand the concepts I am explaining. There is no blind rule here. There is no strict rule. All the rules comes from experience and common sense, everything. Now you tell me, as a student, what you understand. When lot of packets are coming to receiver, what should be the receiver's decision? So always piggybacking is not the idea. That's why, so these are all various ideas your TCP follows. One is, if there is a data, piggyback it. Second one, if there is no data, for first time you keep quiet. Second time, if there is no data, already one packet is pending, we did not send the acknowledgement. Now this is the high time to send the acknowledgement. Otherwise, what is the reason you are not sending acknowledgement? To avoid the congestion, right? To not to disturb your routers, right? Then if you don't send lot of, if you don't send acknowledgements for lot of packets, then eventually your sender will time out, and he will send the data again. He will retransmit, correct? Then again that will lead to, I can say congestion. To avoid that, so what we do is, for second packet, we just ask application layer again, my dear application layer, you have any data now? No. For what about previous acknowledgement, previous packet, is it acknowledged? We remember that data, okay? So TCP will check. We did not acknowledge previous one. Now if you don't acknowledge this one, that's a dangerous thing. Then immediately it will send acknowledgement, okay? So ACK, what is that? 300. We are expecting 300th byte. So this is the way alternatively we do the acknowledgement, okay? So fourth case we will see. Now the fourth one, out of order packet. Whenever out of order packet comes, example P1, then P2, P3, P4. Same story. P1 sequence number is 100, P2 is 200, P3 is 300, P4 is 400. P1 comes, let's take P5 also, which is 500. Then P2 is, let's say, missing, otherwise we don't know about P2. After that, let's say P3 comes, P4 comes, P5 comes. Then we say that P3's arrival is out of order arrival. We say P3 is out of order packet. Okay. Now whenever P1 comes, then really if receiver sends an acknowledgement, what that would be? That would be ACK 200. But that means we are expecting a packet with 200 sequence number. Then if P3 comes, it is out of order. What to do? Should I keep quiet or should I do anything? You have to send, that means the receiver should send ACK expected sequence number 200. Why, sir? I will tell you. If you do that, what happens? For P3, P4, P5, all are out of order packets. You will be simply sending ACK 200 three times. Then the sender will understand that this 200 is not received by receiver for 3 iterations. That means, so each one, example, when it will, when ACK of 200 will be received by your receiver, definitely after one round trip time of time, right? Similarly, this ACK 200 also will be received after one round trip time. This one also after a round trip time, correct? After 3 round trip times, still receiver is telling that ACK 200. That means 200 is most probably missing. Then immediately sender actually sends that packet first. This P packet with 200 sequence number will be sent rather than the sequence. Understand? So that is the strategy generally your sender can follow. Remember one thing. We know that we are following sliding window protocol, right? We actually wanted to send P1, P2, P3, P4, P5. Assume that, let's say our window size is 10. Okay. P10. So your sender was seriously sending P1, then P2, then P3, then P4, then P5. When P3 sent, what happened? He got ACK 200. Again, for P4 also he got ACK 200. For P5 also ACK 200. Now, whenever these 3 acknowledgements are received, by that time, let's say P6, P7 also sent. Now, this is the time for your sender to send P8. But sender will think like this. Why I got 3 acknowledgements like this? That means definitely 200 might have been missing. Then he will stop this process and he will send P2 again. Though P2 has not timed out. That means P2's alarm, otherwise P2's timer is not timed out also. We send that first because there is a high chance that P2 may be missing. So that's why this rule will be helpful. From now onwards, receiver will do this one. Whenever he receives a out of order packet, he will send ACK expected packet number. Understand? Now we'll see missing packet. Missing packet is like this. You have P1, then P2, then P3, then P4. P1 has arrived, P2 is missing at this moment, then after that P3 has arrived, after that P4. So your TCP, remember one thing, it accepts actually out of order packets, but while giving to application layer, once it forms all the correct order, that means once it it is having the right order, then it will send. At this moment P1, P3, P4 will be stored by your TCP. Once P2 comes, then all that P1, P2, P4 will be given to application layer. At this moment, let's say this time P2 is missing, correct? What if P2 comes at this point of time? Yes, it is possible in network, right? In network we can't predict the delays. So P2 might have taken a different route and it is arrived here. Then what are we going to do is a question. We are talking about acknowledgements. What acknowledgement you send if you really want to send? Then at this moment, so P2, it is missing segment, right? For that, simply we take it first of all, we accept it. Then see P1, P2, P3, P4, sequence numbers 100, 200, 300, 400. So far, we have formed some, packets up to 400. Now I have to start with 500th packet. That means I am expecting now 500. That's why here expected packet sequence number will be sent ACK 500. Now if you see all the acknowledgements, you understand. We said initially, example, assume that for every packet if you send acknowledgement, then what will be the acknowledgements we will see. So for P1, if and all if we send acknowledgement, it will be ACK 200. That means we are expecting 200. Then if P3 comes out of order packet, for that acknowledgement will be ACK 200 because we are expecting 200. Now again ACK 200. Though we have received 400th packet, that means packet with 300, sorry, sequence number 100, 200, 300, 400. Yes. So P4 with sequence number 400, still we send ACK 200. Why? Because so far we received only up to 200 in a order, but remaining things are not order. But first time when you get P2 at this moment of time, suddenly we send ACK 500. Whenever it is received by your sender, your sender will be very happy and it will think that we have to, it will think that 100 to 500 all are completely received. That is the way your sender understands the things. That's why this is also important. Now last one, duplicate segment. What is the meaning of that? We will see. Simple. Sometimes what happens, this is the situation. Packet 1 is sent, then you did not, let's say you sent acknowledgement, but that is not received by example ACK 200, but that is not received by your receiver. Then again P1 will be transmitted one more time if the associated timer with P1 is timed out, correct? Then what are we going to do is the question. This is nothing but duplicate segment. Whenever duplicate segment comes, we simply say that, my dear sender, this is my expected acknowledgement. I don't know why duplicate has arrived, but example P1 is already received by me. So here example, this is 100. We sent ACK 200, again we send, and we think that probably that may be missing in the transit, correct? So remember one thing, whenever duplicate segment arrives, we simply send acknowledgement if and all if we want at that time, by simply saying that I want currently this packet, okay, expected packet number will be sent, ACK expected number. That's it, as usual. So this is about all the various ways of sending the acknowledgements, right? So remember this. Now we'll see the last aspect of error control, that is retransmission. So what is retransmission? We will see. You have sender and receiver. Sender sends a packet, correct? After that receiver receives and he will send acknowledgements, but not regularly. Sometimes he may not give acknowledgement for a given packet. Sometimes acknowledgement may be lost. In that situation, how sender will know that the packet has to be retransmitted? How he will guarantee that his packet is successfully reached? For that he is going to use a timer. What he will do, if he won't get any acknowledgement for a packet, then he will maintain a timer. Once timer is timed out, then he will send the packet again. Further, TCP is also going to use that concept, that is also known as retransmission. How TCP is going to do the retransmission, we'll see generally. So what it will do is, it will have a queue. These are all, let's say, set of packets which are not acknowledged by your receiver so far, and there will be a timer called retransmission timeout. So that timer will be fixed to some value, let's say 30 seconds. What are we going to do is, after this this timer times out, let's say 30-second time is expired, then immediately we'll take the first packet in this queue. These are all not acknowledged. Then take P1 and send it again. P1 will be sent. Then again you start the timer with 30 seconds. Okay, again if this timer times out before you get acknowledgement for anything, then again we have to restart it. That is one thing. Second, sir, what if we get the acknowledgement which we are expecting? Example, let's say you sent P1 properly, okay, and you got acknowledgement too for P1, acknowledgement for P1. Before this RTO times out, what are we going to do? We are going to do again restarting the timer. That means we initialize it to again 30 seconds and do it again. So whenever you get the acknowledgement in the right times, then we restart the timer. Second thing, whenever timer times out, we send top of the queue, otherwise front of the queue, and we send that packet. Okay, in the, let's say, early morning, what we do, I will tell you. These are all the packets, P1, P2, P3. What I do is I take the timer first, then I put it as 30 seconds, then I send P1. In the transit, let's say P1 is lost, let's say receiver doesn't know about P1, he will not send any acknowledgement, then in that case this will become 0, then again I'm going to send P1. Okay, forget about P2, P3, whether I sent P2 or P3 doesn't matter, but P1 will be definitely sent after this time, 30 seconds. Whenever I'm sending the P1, then this will be initialized to again reinitialize to 30. Assume that, let's say, this time acknowledgement comes in the correct time. If it won't come, then again this will become 0. We do the same thing. If acknowledgement comes, then we are going to do what? We simply remove P1. My dear P1, yes, you are finally acknowledged. Then there is no work with you. Okay, I have to finally P2 and P3 has to be acknowledged. P1 is acknowledged. Immediately make it 30 again. Then I don't know whether P2 P3 sent or not. Eventually, let's say whenever a new acknowledgement comes, then this timer will be set to 30 again. Now at any time, if some acknowledgement won't come for 30 seconds of time, then that will become 0. Then at this moment, let's say still P2 P3 are not acknowledged, but so far acknowledgement did not come for P2 and P3, then this timer will become timeout. Then we send P2. So that's it. There are only two cases. Okay, so we send P2. Again, if you don't get acknowledgement, we initialize it to 30. Again, we send it. Eventually, we get it. Correct. When you get it, then we remove it and we send the next packet. In that way, this process will go on. So idea is important. That's it. Okay, not exact details. 100% details are not required, but how we are using this timer. When acknowledgement comes for any packet, it is the right acknowledgement, then make it again start. Okay, second one, whenever acknowledgement RTO times out, then send the outstanding packet, which is nothing but just first element of the queue. These are the only two things. Okay, now once it is done, second thing you should understand, already I explained you 3 acknowledgements. 3 ACK is very important. What is this, sir? Apart from this timer, we are going to use these 3 ACKs to do the retransmission. Already one is done. Case number 1. Whenever timer times out, we send. Second thing, if you get 3 duplicate acknowledgements, wrong acknowledgements I can say, ACK, ACK, ACK. 3 ACKs. Did you remember that? Already I explained you. ACK 200, ACK 200, ACK 200. At this moment, let's say you were sending 400th packet, 500 sequence number packet, 600 packet. See this scenario. What is happening? Why are you getting ACK 200 though you are sending 400, 500, 600? That means definitely 200 packet is not arrived there. Then immediately after getting these 3 ACKs, though the timer is not timed out, still it is showing 15 seconds. Okay, then this is your queue. In that queue you have a packet with sequence number, let's say something, let's take P2 with sequence number 200, P3 with sequence number something 300, P4 with sequence number 400, in that way. Okay, now whenever you get ACK 200, though timer is not timed up, still we send P2 immediately. When? Immediately after getting the third acknowledgement. Why? Timer is not timed up, right? But why we do that? Because the history, otherwise the experience says that the 3 acknowledgements like this definitely says that the packet is missing. Otherwise, it won't take much time. Why 3 times you got ACK 200? That means within 3 round trip times, ACK 200, ACK 200, ACK 200 informs that this takes 1 round trip time to get, for occurring these incidents, right? This acknowledgement again comes means 1 more round trip time. this acknowledgement one more round trip time almost. Okay, then after 3 round trip times also still the packet so called P2 did not arrive there, that's why he is shouting. Then immediately we have to send it, though our timer is not properly timed up. Okay, so that means this is, sir, why you are not believing timer that is set by ourselves, right? Then maybe sender did not know proper details, that's why he put little bit a longer timer, right? Sometimes we do that, correct? So that's why this is going to be the indication. Remember, these are all comes from experiences. What is the second experience? Whenever you get one acknowledgement that is wrong acknowledgement, I'm not expecting this one, correct? Whenever you get 3 wrong acknowledgements, 200, 200, 200 from your receiver, immediately send the missing packet. Okay, so these are the two strategies for retransmission. Understand?